Hello my dear students. So welcome back to chemistry online class. So in the previous class I have already explained the basic quantities or the fundamental quantities of matter and their SI unit. With the help of these basic quantities or the fundamental quantities of matter, so we derived 8 important quantities and their SI units also. In addition to these fundamental quantities and their SI unit, derived quantities and their SI unit, so in the last session we discussed about what are the differences between mass and weight of the chemical substance. What are the differences between mass and weight of the chemical substance, and how the mass of the chemical substance is measured accurately in the laboratory. Then second important quantity called as volume of the chemical substance, the different units used to express the volume of the chemical substance, and the important apparatus used to measure volume of the chemical substance in the laboratory. In addition to these two important quantities, the one more important quantity called as a thermodynamic temperature, or in simple words we call it as a temperature factor. Even in the temperature factor also, so already we discussed about, so the temperature factor, even in temperature factor also, so the temperature, the definition of a temperature is discussed in the yesterday's class. The instrument used to measure the temperature of a substance is discussed in the discussed. Then what are the different type of thermometers are used, then what are the different scales of temperature. All these important points are discussed in the previous session only. Okay, now in the today's session we'll discuss about the fractions and multiples used in SI system. The fractions and multiples used in SI system. Then one more concept called as a scientific notation, or we call it as exponential notation, and one more very important concept called as the significant figure concept. So before these scientific notation, significant figures, then multiples and fractions used in SI system, so once we'll recall the temperature, then mass and weight of the chemical substance and volume of the chemical substance. Students, as you already know that the mass of the chemical substance, is always constant value, whereas weight of the chemical substance differ from one place to another place due to the change in gravitational force. That means due to the change in gravity, students. And mass of the chemical substance, the mass of the chemical substance is measured accurately by using analytical balance or by using the chemical balance in the laboratory, students. And the second important quantity is volume of the chemical substance, and this volume of the chemical substance is expressed in terms of meter cube, it is expressed in terms of decimeter cube, it is expressed in terms of milliliter, liter, and so on. And the various types of apparatus are used to measure volume of the chemical substance, students. You just recall, yes, tell me what are the various types of apparatus used to measure volume of the substance, students? Yes, very good. So pipette is used to measure volume, burette is used to measure volume, conical flask measuring cylinder. Okay, conical flask measuring cylinder, measuring flask, or we call it as a volumetric flask. All these different types of apparatus are used to measure the volume of the chemical substance. And now the third quantity is temperature. We all know that temperature, it is defined as the measure of degree of hotness or coldness of a body. Degree of hotness or coldness of a body, that is nothing but a temperature factor. And to measure the temperature, one of the important apparatus used is thermometer. Yes, tell me, students, how many types of thermometers are used? Tell me how many types of thermometers are there, students? Yes, very good. How many types? Three different types. What are those, students? One is a clinical thermometer, second one is a laboratory thermometer, and the third category is nothing but minima and maxima thermometer. So three different types of thermometers are used to measure the temperature of a system. Okay, and here temperature. Here three different scale of temperatures are used. Three different scale of temperature. Yes, tell me, students, what are the three different scale of temperature? Yes, first one is a Celsius scale, second one is called as a Fahrenheit scale, and the third category we call it as a third one is nothing but Kelvin scale. Degree Celsius, Fahrenheit and Kelvin scale, student. And already you know how to convert degree Celsius into Kelvin scale and how to convert Kelvin scale into degree Celsius. Similarly, how to convert Fahrenheit scale into degree Celsius is known, and degree Celsius to Fahrenheit is also known. Even this conversion is also discussed in the last session only. Now, with the help of these important quantities, so a measured physical quantity. Listen carefully, students. A measured physical quantity is expressed in two different terms. With the help of these important points, so a measured physical quantity is expressed in two parts. A measured physical quantity is expressed in two parts. The first part is called as a numerical value, and the second part is nothing but its corresponding unit. Please listen this point carefully. Already you know the physical quantities and their SI unit, and derived quantities and their SI unit, students. Now here a measured physical quantity, it is expressed in two different parts. The first part is called as a numerical value, and the second part is called as its corresponding unit. And in SI system, the number of multiples and fractions are used, students. The fractions and multiples are used in SI system. So let us discuss the multiples used in SI system and their prefix word, and the number of fractions used in SI system and their prefix word, students. Now here the multiples. Listen it carefully. Multiples. So 10. So what is the prefix word for this multiple? Deca. If it is 10 to the power of 2, 10 raised to 2 means hecto. Third one is 10 to the power of 3. 10 raised to 3 means kilo. So 10 raised to 6 means mega. Similarly, 10 raised to 9 means giga. 10 raised to 12 means tera. 10 raised to 15 peta. 10 raised to 18 exa. 10 raised to 21 jeta. Then 10 raised to 24 iota. See, all these are nothing but different multiples used in SI system and their prefix word, students. Please remember these multiples and their prefix word. All these terms are used in the numerical calculation, students. So the number of multiples and fractions are used in SI system, and all these are nothing but the multiples used in the SI system and their prefix word, students. And similarly, the fractions are also used. In SI system. So here all these are nothing but the number of fractions, the commonly used fractions in an SI system. So 10 raised to minus 1. 10 raised to minus 1 means the prefix word for this fraction is deci. 10 to the power of minus 2 means the prefix word for this is centi. Similarly, 10 raised to minus 3 milli. 10 raised to minus 6 micro. 10 raised to minus 9 nano. 10 raised to minus 12 pico. 10 raised to minus 19 femto. 10 raised to minus 18 atto. 10 raised to minus 21 jatto. So 10 raised to minus 24 yatto. hecto. So all these are nothing but different fractions used in SI system and their prefix word. Students, you please remember these multiples and fractions used in an SI system. Okay, is there any doubt in this? The same concept you are going to study even in physics part also under units and measurement chapter. Okay, so here you just remember these multiples and fractions used in SI system, students. Yes, tell me, students, so what is the prefix word for 10 to the power of minus 9 fraction? Yes, very good. Nano is the prefix word. Tell me, student, what is the prefix word for a fraction 10 raised to minus 18? Atto. What is the prefix word for the fraction 10 raised to minus 3? Milli. So what is the prefix word for the multiple 10 to the power of 6? Mega. So what is the prefix word for the multiple 10 raised to 15? Peta. Okay, so please remember all these multiples and fractions used in an SI system, students. And now with the help of these multiples and fractions used in SI system, let us switch on to the one more important concept. The one more important concept is nothing but the scientific notation, or it is also called as exponential notation. Scientific notation, or it is also called as exponential notation. See, a scientific notation. This scientific notation or the exponential notation, it is defined as the convenient way of expressing the extreme numbers. Listen the definition of scientific notation carefully. ನೋಡಿಲ್ಲ scientific notation ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ it is the convenient way to represent a very small number or a very big number. That itself is nothing but scientific notation. ನೋಡ್ರಿ ಅತಿ ಸ್ಮಾಲ್ ನಂಬರ್ ಇದ್ರೂ ನಾವು ಅದನ್ನ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಶನ್ ಒಳಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಬಿಗ್ ನಂಬರ್ ಇತ್ತಂದ್ರೂ ನಾವು ಅದನ್ನ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಶನ್ ಒಳಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. ಹೌದಾ? ಯಾವ ರೀತಿ ನಾವು ಈ ಸ್ಮಾಲ್ ಮತ್ತೆ ಬಿಗ್ ನಂಬರ್ ಅನ್ನ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಶನ್ ಒಳಗ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನ ನಾವಿಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ಕೊತಾ ಹೋಗೋಣ. ಹೌದಾ? ಸೊ ಯು ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ scientific notation, it is a convenient way of expressing the extreme numbers, or the scientific notation, it is the convenient method to represent a very small number or a very large number. That itself we call it as a scientific notation or exponential notation, students. Here the general representation for the scientific notation. Then how to represent the large number and small number in a scientific notation? For this representation, so to write the very small number by using exponential notation, to write the very large number by using the scientific notation, first we'll discuss the general representation for the scientific notation, student. The general representation for the scientific notation is, the general representation for the exponential notation is n into 10 to the power of x, or we can write it as a into 10 to the power of b. Either you can use n into 10 raised to x, or you can use a into 10 raised to b. ನೀವು ಈ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ನಾದ್ರೂ ಯೂಸ್ ಮಾಡಬಹುದು, ಇಲ್ಲಪ್ಪ ಅಂತಂದ್ರೆ a into 10 raised to b ಅನ್ನೋ ಟರ್ಮ್ ಅನ್ನಾದ್ರೂ ಯೂಸ್ ಮಾಡಬಹುದು. Otherwise you can use m into a raised to n. That representation is also used for scientific notation or exponential notation, students. ಹೌದಾ? ಸೊ ನಿಮಗೆ ಸ್ಟಡಿ ಮಟೀರಿಯಲ್ ಏನು ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿದೀವಲ್ಲ, ಆ ಸ್ಟಡಿ ಮಟೀರಿಯಲ್ ಒಳಗ n into 10 to the power of x ಅನ್ನೋದು ಜನರಲ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಫಾರ್ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್, ಸ್ಟೂಡೆಂಟ್ಸ್. ಹೌದಾ? ಸೊ ನೀವು ಇದನ್ನಾದ್ರೂ ಯೂಸ್ ಮಾಡ್ರಿ, ಅಥವಾ a into 10 to the power of b ನಾದ್ರೂ ಯೂಸ್ ಮಾಡ್ರಿ. Otherwise you can use m into 10 raised to n also. Okay, so this is about the general representation for the scientific notation, or we call it as exponential notation, students. And here in this general representation, this capital N stands for coefficient and it is a real number. Listen the terms carefully. What the capital N in the general representation indicates, students? Coefficient and it is a real number. Okay, ನೀವು ಈ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಏನಾದ್ರೂ ಯೂಸ್ ಮಾಡ್ತಿದ್ರಿ ಅಂತಂದ್ರ ಇಲ್ಲಿ n ಅಂತ ತಗೊಳ್ರಿ. ಇಲ್ಲಪ್ಪ ನಾವು a into 10 raised to b ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರ where a is nothing but coefficient and is a real number. ಹೌದಾ? ಸೊ n ಆದ್ರೂ ಇರ್ಲಿ ಅಥವಾ ಸ್ಮಾಲ್ a ಆದ್ರೂ ಇರ್ಲಿ, ಸೆಕೆಂಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಒಳಗೆ ಆ ಟರ್ಮ್ ನಮಗೆ ಏನ್ ಇಂಡಿಕೇಟ್ ಮಾಡತ್ರಿ? ಸೊ ಕೋಯಿಫಿಷಿಯಂಟ್ ನ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತ. ಅಂಡ್ ದಿಸ್ ಕೋಯಿಫಿಷಿಯಂಟ್ ಇಟ್ ಈಸ್ ಅ ರಿಯಲ್ ನಂಬರ್, ಸ್ಟೂಡೆಂಟ್ಸ್. And now coming to the one more important part, 10 to the power of x, 10 to the power of b, where x or b indicates exponent which is an integer. Listen this point carefully, students. ನೋಡ್ರಿ, x ಮತ್ತೆ b, x ಅಥವಾ b ಅನ್ನೋ ಟರ್ಮ್ ನಮಗೆ ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡತ್ತಂದ್ರ, ಸೊ x or b are nothing but exponent which is an integer, students. ಅಂದ್ರೆ x ಅನ್ನೋದು ಏನಪ್ಪ ಇಲ್ಲಿ exponent ಅಂತೀವಿ, and this x always it is an integer. And you know what is mean by real number and integer concept also. ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಒಳಗೆ ರಿಯಲ್ ನಂಬರ್ ಅಂದ್ರೆ ಏನು ಮತ್ತೆ ಇಂಟೀಜರ್ ಅಂದ್ರೆ ಯಾವುದು ಅಂತ ಹೇಳಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರುತ್ತೆ, ಹೌದಾ? ಸೊ ಹಿಯರ್ ಯು ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿ ಜನರಲ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಅಂಡ್ ದ ಟರ್ಮ್ಸ್ ಇನ್ವಾಲ್ವ್ಡ್ ಇನ್ ದಿಸ್ ಜನರಲ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್, ಸ್ಟೂಡೆಂಟ್ಸ್. Yes, tell me what is the general representation for the scientific notation? N into 10 to the power of x, or you can write it as a into 10 to the power of b. So in this n into 10 raised to x, n indicates coefficient and it is a real number, and x indicates exponent which is an integer, students. With this general representation explanation, so let us discuss how to write the small number in a scientific notation, and how to write the big number, how to write the very large number in a scientific notation, students. See, while writing the scientific notation for a very large number, while writing the scientific notation for a very small number, always count the number of digits and then shift the decimal point, students. Listen this important point carefully. ನೋಡ್ರಿ, ನಾವು ಯಾವಾಗಲೂ ಸ್ಮಾಲ್ ನಂಬರು ಮತ್ತೆ ಬಿಗ್ ನಂಬರ್ ನ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ನೋಟೇಷನ್ ಒಳಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡುವಾಗ ಕೌಂಟ್ ದಿ ನಂಬರ್ ಆಫ್ ಡಿಜಿಟ್ಸ್ ಅಂಡ್ ದೆನ್ ಶಿಫ್ಟ್ ದಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್. ಅಂದ್ರೆ ನಾವು ನಂಬರ್ ಆಫ್ ಡಿಜಿಟ್ಸ್ ನ ಕೌಂಟ್ ಮಾಡಿಬಿಟ್ಟು ಆಮೇಲೆ ನಾವೇನ್ ಮಾಡ್ತೀವ್ರಿ, ಆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ನ ಶಿಫ್ಟ್ ಮಾಡ್ತೀವಿ. ಐದರ್ ಯು ಶಿಫ್ಟ್ ದಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಟುವರ್ಡ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಆಫ್ ದಿ ನಂಬರ್, ಆರ್ ಯು ಶಿಫ್ಟ್ ದಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಟುವರ್ಡ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಆಫ್ ದಿ ಗಿವನ್ ನಂಬರ್. So either you shift the decimal point towards left hand side of the given number, or you shift the decimal point towards right hand side of the given number, students. So always while writing the exponential notation for a given number, or while writing the exponential notation for a given number, so count the number of digits and then shift the decimal point. With the help of this point, here in case of exponent, already you know the term. In this general representation, this x indicates exponent which is an integer. That small b indicates exponent which is an integer, students. And here exponent, so this exponent it may be positive in some numbers, and this exponent it may be negative in some given numbers, students. Listen this point carefully. ಇಲ್ಲೇನು ಎಕ್ಸ್ ಅಥವಾ ಬಿ ಅನ್ನೋದೇನಿದೆಲ್ಲ ಎಕ್ಸ್ಪೋನೆಂಟು, ಈ ಎಕ್ಸ್ಪೋನೆಂಟು ಕೆಲವೊಂದು ಟೈಮು ನೆಗೆಟಿವ್ ಇರುತ್ತೆ ಆ್ಯಂಡ್ ಇನ್ ಸಮ್ ಕೇಸಸ್ ಇಟ್ ಮೇ ಬಿ ಅ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ಲೆಟ್ ಅಸ್ ಡಿಸ್ಕಸ್ when this exponent becomes a positive and when this exponent becomes a negative. Students, exponent becomes a positive. Listen, exponent becomes a positive. Exponent becomes a positive only when we shift the decimal point towards left hand side. Listen this first point carefully. So when the exponent becomes a positive, students, when we shift the decimal point, towards the left hand side, then only exponent becomes a positive. Students, then when this exponent becomes a negative, very good, when we shift the decimal point towards right hand side, ಅಂದ್ರೆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ ನೀವು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಅದೇ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ ನಾವು ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಇಟ್ ಬಿಕಮ್ಸ್ ನೆಗೆಟಿವ್. ಸ್ಟೂಡೆಂಟ್ಸ್, listen this point carefully. So the exponent it becomes positive only when we shift the decimal point towards left hand side, whereas exponent it becomes negative only when we shift the decimal point towards right hand side. Students, is it clear? Is there any doubt in this point? So let us take an example. 0.005 is a given number. Student, now let us represent this given number in a scientific notation or in an exponential notation. And always you please remember, while writing the scientific notation for a given number, while writing the exponential notation for a given number, you please count the number of digits and then you shift the decimal point. So here the given number is 0.005. So let us count the number of digits. So 1, 2, 3. Then you shift the decimal point. So this number is expressed in terms of 5 into 10 to the power of minus 3. This is the scientific notation or exponential notation for a given number. Students, please remember this scientific notation concept. 0.005 is a very small number, and this small number is expressed by using scientific notation concept. And here the exponent becomes negative. Yes, tell me student, when the exponent becomes negative, when we shift the decimal point towards right hand side, then only exponent becomes negative. Students, so this is the scientific notation for this given number. And similarly, the one more example is 6,000. So let us represent this large number in a scientific notation. Let us represent this 6,000 by using exponential notation or by using scientific notation. 6,000. So 6,000, we can represent this 6,000 in the form 6 into 10 to the power of plus 3. 6 into 10 raised to plus 3. Once again, in this case also count the number of digits and then you shift the decimal point. So 1, 2, 3, and here you put the decimal point. Students, so 6.0 or 6 into 10 to the power of plus 3. So this is regarding the scientific notation for a given number. Students, so one is a very small number and one is a very large number. You please recall the definition of scientific notation. The exponential notation or the scientific notation, it is the convenient method. To represent a very small number or a very big number. Okay, this itself we call it as a scientific notation part. And always while representing the scientific notation, you please count the number of digits and then you shift the decimal point. If you want to shift the decimal point towards the left hand side or shift the decimal point towards the right hand side. And the exponent, it becomes negative only when we shift the decimal point towards the right hand side, and the exponent becomes positive when we shift the decimal point towards the left hand side, students. ಅಂದ್ರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ನಾವು ಡಿಜಿಟ್ ನ ಕೌಂಟ್ ಮಾಡಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ನ ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ ಎಕ್ಸ್ಪೋನೆಂಟ್ ನಮಗೆ ನೆಗೆಟಿವ್ ಆಗತ್ತೆ, ಹೌದಾ? ಸೊ ಅದೇ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಪಾಸಿಟಿವ್ ಯಾವಾಗ ಆಗತ್ರಿ? when we count the number of digit and shift the decimal point towards the left hand side. So this is regarding the scientific notation, or we call it as a exponential notation, students. Is there any doubt in this example? Scientific notation part is clear. Yes, tell me, what is the general representation for the scientific notation? Very good. What is the general representation? N into 10 raised to x, or you can represent a into 10 to the power of b, where capital N or a is coefficient and is a real number, and x or b is exponent which is an integer, students. Is it clear? So we'll take some more example based on this scientific notation or exponential notation concept. You please remember one very important point while writing scientific notation. You please count the number of digits and then you shift the decimal point, students. And here with the help of this explanation, so let us take a first example. So 0.218. So this is the given number. So let us express this given number by using scientific notation or in exponential notation, students. So here 0.218. So let us shift this decimal point after one digit. So count the number of digit and then shift the decimal point, students. We can write this number in the form 2.18 into 10 to the power of minus 1. You please listen this solution carefully. ನೋಡ್ರಿ, ಇಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡಿದ್ದೀನಿ ಅಂತಂದ್ರೆ ಈ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ನ ಜಸ್ಟ್ 1 ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ದೇನೆ. 1 ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ಶಿಫ್ಟ್ ಮಾಡಿರೋದ್ರಿಂದ ನಮಗೆ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಏನಾಯ್ತ್ರಿ? 1 ಆಯ್ತು. ಆಮೇಲೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ನಾನು ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ನ ಶಿಫ್ಟ್ ಮಾಡಿರೋದ್ರಿಂದ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಬಿಕಮ್ಸ್ ನೆಗೆಟಿವ್. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಕೇರ್ಫುಲಿ. So when the exponent becomes negative, students, when we shift the decimal point towards right hand side, okay, now after the decimal point is shifted after only one digit, so therefore the scientific notation for this number is 2.18 into 10 raised to minus 1. Or suppose if you want to shift this decimal point after 2 digits, ಇಲ್ಲಪ್ಪ ನಾನು 2 ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ನನಗೆ 2 ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ 10 raised to minus 2 ಫಾರ್ಮ್ ಒಳಗೆ ಬೇಕಿತ್ತು ಅಂತಂದ್ರೆ you please shift this decimal point after 2 digits. We can write the given number in the form 21.8 into 10 raised to minus 2 also. Similarly, suppose if you want to shift the decimal point after 3 digits, so what is the scientific notation, students? 218 into 10 to the power of minus 3, students. So like this we write the scientific notation or exponential notation, students. Note now 10 raised to minus 1 form ಒಳಗಾಗಲಿ 10 raised to minus 2, 10 raised to minus 3. ಅಂದ್ರೆ ನ್ಯೂಮೆರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಒಳಗ ನಮಗೆ ಯಾವುದು ಫಾರ್ಮ್ ರಿಕ್ವೈರ್ಡ್ ಇರುತ್ತಲ್ಲ ಆ ಫಾರ್ಮ್ ಪ್ರಕಾರ ನೀವು ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಅನ್ನು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು. ಬಟ್ ಒನ್ ಥಿಂಗ್ ಯು ಕೀಪ್ ಇಟ್ ಇನ್ ಮೈಂಡ್, ಪ್ಲೀಸ್ ಕೌಂಟ್ ದಿ ನಂಬರ್ ಆಫ್ ಡಿಜಿಟ್ಸ್ ಅಂಡ್ ದೆನ್ ಶಿಫ್ಟ್ ದಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್. ಈಗ ನಮಗೆ 10 raised to minus 1 ಫಾರ್ಮ್ ಒಳಗೆ ಬೇಕಿತ್ತಪ್ಪ ನಂಬರ್ ಅಂತಂದ್ರೆ ಜಸ್ಟ್ ಒಂದು ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ಶಿಫ್ಟ್ ಮಾಡಿ. ಇಲ್ಲಪ್ಪ ನಮಗೆ 10 raised to minus 3 ಫಾರ್ಮ್ ಒಳಗೆ ಬೇಕಿತ್ತು ಅಂತಂದ್ರೆ ಸೊ ಶಿಫ್ಟ್ ದಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಆಫ್ಟರ್ 3 digits like this 1 2 3. Count the number 1 2 3, then you shift the decimal point here. Okay, that means 218 into 10 raised to minus 3. So this is regarding the scientific notation, students. And now similarly the second example is 0.0108. 0.108. Again in this case also the first point is, let us shift this decimal point after one digit. If you shift this decimal point after one digit means this number becomes 0.108 into 10 to the power of minus 1. Suppose if you want to shift this decimal point after two digit, so this becomes 1.08 into 10 to the power of minus 2. So one more form is 10.8 into 10 raised to minus 3. So one more form is 108 into 10 raised to minus 4. So all these are nothing but possible scientific notation for the given number, students. ಅಂದ್ರೆ ನಮಗೆ ನ್ಯೂಮೆರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಒಳಗ ಯಾವ ಫಾರ್ಮ್ ಒಳಗೆ ಬೇಕಿರತ್ತಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ ನೀವೇನ್ ಮಾಡ್ರಿ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ನೋಟೇಷನ್ ಅನ್ನ ಬರೀರಿ. ಈಗ ಸಪೋಸ್ ಎಕ್ಸಾಮಿಗೆ ಏನಾದ್ರು ರಿಪ್ರೆಸೆಂಟ್ ದಿಸ್ ನಂಬರ್ ಇನ್ ಆನ್ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್, ಎಕ್ಸ್ಪ್ರೆಸ್ ದಿಸ್ ನಂಬರ್ ಇನ್ ಆನ್ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಅಂತ ಕೊಟ್ಟರು ಅಂತಂದ್ರೆ, ಸೊ ನೋ ನೀಡ್ ಟು ರೈಟ್ ಆಲ್ ದೀಸ್ ಪಾಸಿಬಿಲಿಟೀಸ್. ಯು ಜಸ್ಟ್ ರೈಟ್ ದಿ ಫಸ್ಟ್ ಪಾಸಿಬಿಲಿಟಿ 1.108 into 10 raised to minus 1 or you write 1.08 into 10 raised to minus 2. ಹೌದಾ? ಸೊ ಎಕ್ಸಾಮ್ ಕೇಳಿದಾಗ ಎಲ್ಲಾ ಪಾಸಿಬಿಲಿಟಿ ಬರೆಯೋದು ನೆಸೆಸರಿ ಇಲ್ಲ. ಎಲ್ಲಿ ನಿಮಗೆ ಫಸ್ಟ್ ನಾನ್ ಝೀರೋ ಡಿಜಿಟ್ ಇರತ್ತಲ್ಲ ಅಲ್ಲಿಂದ ನೀವು ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಅಂದ್ರೆ 1.08 into 10 raised to minus 2 ಅಂತ ಬರೆದ್ರೆ ಸಾಕು. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್, ಸ್ಟೂಡೆಂಟ್ಸ್. Is it clear for you? Is there any doubt in this scientific notation? Now let us take a third example, 0.121. Express this given number in a scientific notation. Okay, so the scientific notation for this number is 1.21 into 10 to the power of minus 1. So this is the scientific notation for the 0.121, students. ಇಷ್ಟು ನೀವು ಎಕ್ಸಾಮಿಗೆ ಬರೆದ್ರೆ ಸಾಕು. ಹೌದಾ? ಬಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಒಳಗೆ ನಮ್ಗೆ ಏನ್ ರಿಕ್ವೈರ್ಡ್ ಇರುತ್ತಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ ಮಾಡಬಹುದು. ಈಗ ನಾನು ಇಲ್ಲಿ 1 ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ಶಿಫ್ಟ್ ಮಾಡಿದೀನಿ, ಸೊ ಯು ವಿಲ್ ಗೆಟ್ ದಿಸ್ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್. ಈಗ ನಾನು 2 ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನು ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ ಯು ವಿಲ್ ಗೆಟ್ ದಿ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಇನ್ ದ ಫಾರ್ಮ್ 12.1 into 10 to the power of minus 2. If I shift the decimal point after 3 digit means you will get the scientific notation 121 into 10 to the power of minus 3. These are the possible scientific notation for the number 0.121, students. Is it clear? Is there any doubt in this third example? Now switch on to the fourth example, 0.00000056. This is the given number, and here the number is very small. And now let us represent this small number in a scientific notation or in an exponential notation, students. 0.5056 given number, and here by using scientific notation, the scientific notation for the given number is 5.6 into 10 to the power of minus 6. This is the scientific notation for this given number. Okay, listen here, decimal point is here. Let us shift this decimal point after 5. Okay, so please count the number of digits here. 1 2 3 4 5 6. Then you put the decimal point here. So therefore you will get the scientific notation 5.6 into 10 to the power of minus 6. Yes, tell me, students, what one more possibility for this given extreme number? Yes, very good. So 56, shift the decimal point after 7 digits, that means after 6 years. So the number becomes 56 into 10 to the power of minus 7. So this is regarding the scientific notation for the given extreme number, students. Is there any doubt in this fourth example? And you please remember, in all these four example, the exponent is a negative. And you know when the exponent becomes a negative, students? Just tell me, when the exponent becomes a negative? Very good. The exponent becomes negative only when we shift the decimal point towards right hand side. So then only the exponent becomes negative, students. Is there any doubt in all these four examples? Is it clear? Now let us take a fifth example, 200.16. See 200.16. So let us represent this 200.16 in the form 2.0016 into 10 to the power of plus 2. So this is the scientific notation. ಅಂದ್ರೆ ಈ ಎಕ್ಸಾಂಪಲ್ ಒಳಗ ನಾನು ಈ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ ಏನ್ ಮಾಡಿದೀನಿ, ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದೀನಿ. Again, while shifting the decimal point, you count the number of digits. ನೋಡ್ರಿ ಎಷ್ಟು ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ನಾನು ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ ಶಿಫ್ಟ್ ಮಾಡಿದೀನಿ ಇಲ್ಲಿ. So 1 2, therefore the exponential notation is 2.0016 into 10 raised to plus 2. This is the scientific notation for a given number. Okay, so one more possibility, you can shift this decimal point only after 1 digit also. ಇಲ್ಲ ನೋಡಿ, ನಾನು 2 ಡಿಜಿಟ್ ಕೌಂಟ್ ಮಾಡಿದ ಮೇಲೆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನು ಶಿಫ್ಟ್ ಮಾಡಿದ್ದೀನಿ, ಅದಕ್ಕೆ ನಿಮಗೆ 2.0016 ಬಂತು. ಇಲ್ಲಪ್ಪ ನಮಗ ಎಕ್ಸ್ಪೋನೆಂಟ್ 10 raised to plus 1 ಫಾರ್ಮ್ ಬೇಕಿತ್ತು ಅಂತಂದ್ರೆ ಯು ಜಸ್ಟ್ ಶಿಫ್ಟ್ ದಿಸ್ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಆಫ್ಟರ್ 1 ಡಿಜಿಟ್. ಅಂದ್ರೆ ನಿಮಗೆ ಏನಾಗುತ್ತೆ, 20.016 into 10 to the power of plus 1 into 10 to the power of plus 1. ನೋಡಿ 10 raised to plus 1 means it is nothing but 10 only. Okay, if you multiply this 10 into 20.016, once again you will get 200.16 only. Is it clear? Is there any doubt in this example? Are you all understanding this concept? Okay, now switch on to this next example. So 1265.2, 1265.2. Let us represent this given number in a scientific notation. So the first point is, let us write 126.52 into 10 raised to 1. ನೋಡಿ ನಾನು ಜಸ್ಟ್ 1 ಡೆಸಿಮಲ್ ಗಿಂತ ಮುಂಚೆ ನಾನು ಶಿಫ್ಟ್ ಮಾಡಿದ್ದೀನಿ, ಹೌದಾ? ಜಸ್ಟ್ ಒಂದೇ ಡೆಸಿಮಲ್ ನ ಕೌಂಟ್, ಒಂದೇ ಡಿಜಿಟ್ ನ ಕೌಂಟ್ ಮಾಡಿಬಿಟ್ಟು ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನು ಶಿಫ್ಟ್ ಮಾಡಿರೋದ್ರಿಂದ ಸೊ ಎಕ್ಸ್ಪೋನೆಂಟ್ ನಿಮಗೆ ಇಲ್ಲಿ ಏನ್ ಬಂತ್ರಿ, 1 ಬಂತು, ಹೌದಾ? ಆರ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಇನ್ ದ ಫಾರ್ಮ್, ಸೊ 12.652 into 10 raised to plus 2 or 1.2652 into 10 to the power of plus 3. So these are the possible scientific notation for a given number, students. ಬಟ್ ನೀವು ಎಕ್ಸಾಮಿಗೆ ಬರೆಯುವಾಗ ನೋ ನೀಡ್ ಟು ರೈಟ್ ಆಲ್ ದೀಸ್ ಪಾಸಿಬಿಲಿಟೀಸ್. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದೆ ನಿಮ್ಗೆ, ಹೌದಾ? ಇಲ್ಲಿ ಏನಿರುತ್ತಂದ್ರೆ ಎಸ್ಪೆಷಲಿ ಪಾಸಿಟಿವ್ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಇದ್ದಾಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿಂದ ತಗೊಂಡ್ಬಿಡ್ರಿ, ಈ ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಬಂದ್ಬಿಟ್ರೆ ಎಕ್ಸಾಮ್ಗೆ, ಹೌದಾ? 1.2652 into 10 raised to plus 3. ಬಟ್ ನ್ಯೂಮೆರಿಕಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಒಳಗ ನಮಗೆ ಯಾವ ಫಾರ್ಮ್ ರಿಕ್ವೈರ್ಡ್ ಇರುತ್ತಲ್ಲ ಆ ಫಾರ್ಮ್ ಒಳಗೆ ನೀವೇನ್ ಮಾಡ್ಕೊಡ್ರಿ, ಕನ್ವರ್ಟ್ ದಿ ಎಕ್ಸ್ಟ್ರೀಮ್ ನಂಬರ್ಸ್ ಇನ್ ಅನ್ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್, ಸ್ಟೂಡೆಂಟ್ಸ್. Is there any doubt? So now the third example, 20.181. So let us represent this 20.181 in the scientific notation. So this becomes 2.0181 into 10 to the power of plus 1. This is the scientific notation. Or you can write it in the form of 0.20181 into 10 raised to plus 2. So this is the scientific notation, students. And the fourth example is 75256. This is the given number. It's a very large number, and this large number is expressed, this large number is represented in scientific notation 75256. And in this given number the decimal point is here 0. ನೋಡಿಲ್ಲ, ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಇಲ್ಲ, ಹೌದಾ? ಇದು ಗಿವನ್ ನಂಬರ್ ನಮಗೆ, ಅಂದ್ರೆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಎಲ್ಲಿದೆ, ಆಫ್ಟರ್ ಆಲ್ ನಾನ್ ಝೀರೋ ಡಿಜಿಟ್ಸ್. ಸೊ ಇಲ್ಲಿ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಇದೆ ಅಂತ ಅರ್ಥ, ಹೌದಾ? ಈಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಈ ನಂಬರ್ ಅನ್ನ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಒಳಗೆ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ರಿಪ್ರೆಸೆಂಟ್ ದಿ ಪಾಸಿಬಲ್ ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಫಾರ್ ದಿಸ್ ನಂಬರ್. So first one ಬಂದ್ಬಿಟ್ಟು 75265.6 into 10 raised to how much, students? Very good. 10 raised to plus 1. Why it is 10 raised to plus 1, student? Because the decimal point is shifted only after one digit. ನೋಡಿ, ಜಸ್ಟ್ ಒಂದು ಡಿಜಿಟ್ ಆದ್ಮೇಲೆ ನಾವು ಏನ್ ಮಾಡಿದ್ವಿ, ಶಿಫ್ಟ್ ಮಾಡಿದ್ವಿ. ಹೌದಲ್ಲ, ಇಲ್ಲಿತ್ತು ಒಂದು ಕೌಂಟ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡಿದ್ವಿ ಅಷ್ಟೇ. ಹೌದಾ? ಸೊ ದ ಒನ್ ಮೋರ್ ಪಾಸಿಬಿಲಿಟಿ ಈಸ್ 7526.56 into 10 to the power of. Let's tell me, student, what is the value of x here? What is the value of exponent here? Very good. 2 is the value of exponent. Or one more possible value, 752.656 into 10 to the power of plus 3. One more possible value, 75.2656 into 10 raised to 3. ನೋಡ್ರಿ, ಇದನ್ನ ಮತ್ತೆ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡ್ರಿ, ಇದು ಎಕ್ಸ್ಪೋನೆಂಟ್ ಪ್ಲಸ್ 4 ಆಗುತ್ತೆ. ಇಲ್ಲಿರೋ ಪಾಯಿಂಟ್ ಅನ್ನು ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡ್ರಿ, ದ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಬಿಕಮ್ಸ್ ಪ್ಲಸ್ 5. ಸೊ 7.52656 into 10 to the power of 5. So these are the possibilities of, or all these are nothing but the possible scientific notation for the given number, students. Is there any doubt in these examples? All these examples are clear. Any doubt in the scientific notation or exponential notation, students? Clear ಆಯ್ತು ನಿಮಗೆ? ಏನಾದರೂ ಡೌಟ್ ಇದೆನಾ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಒಳಗೆ? Based on the today's class, the assignment questions. First one is write the prefix word for multiples and fractions. Second one, write the general representation for the scientific notation and explain the terms involved in it. And the third question is express the following in a scientific notation. Here 5 numbers are given. You have to express all these 5 numbers in a scientific notation, students. And in the second question, scientific general representation, you can write n into 10 raised to x, or you can write a into 10 raised to b also. Okay, so all these are today's assignment questions. So with this I conclude my today's class. So in the next session we'll discuss about the significant figure concept, then rules for assigning the significant figure, and the calculation involving the significant figure part. Okay, thank you.